Hey guys, welcome to part 3 of this walkthrough. My name is Faraz, I'm a Cambridge medical student, and in this video I'm going to be showing you my solutions that I use to get full marks in this paper. If you guys want to learn the techniques that I use to score an 8.6 in my actual BMAT, check out sigmamed.co.uk. Me and my friend Hamza are Cambridge medical students, and we've put together a BMAT course that teaches the secrets and tips and tricks that we use to score in the top 10% of the entire country and get into Cambridge using the BMAT. So if you guys are sitting in the BMAT this year for just £30, this course is honestly really worth it, up to date, in detail, and just overall a product that I'm really proud of. Especially at the price we're giving it at, I would definitely recommend checking it out. It only costs £30, that's less than 1 hour of tuitioning, and honestly is a real investment into your BMAT score. But without further ado, here's part 3 of 3 of this walkthrough. Make sure you guys are subscribed because my next few videos are also going to be BMAT full section 2 walkthroughs.
Okay, so part 3 of this walkthrough. A defibrillator provides an electric shock to a heart to restore its normal rhythm. The energy to do this is 125 joules at a steady voltage of 500 volts for a time of 10 milliseconds. What is the current during this process? So first of all, let's convert this into seconds. 10 milliseconds is 1000 milliseconds per second, so this is just 1 over 100 seconds. So we're working with two equations. Energy is equal to power times time. 125 is equal to power over 100. Power is equal to 12,500 watts. And the second equation is that voltage power is equal to current times voltage. So therefore 12,500 is equal to I times 500. 12,500 over 500 is equal to I. So we're essentially just doing 125 over 5 since the zeros cancel out, which is then going to be equal to 25 amps, which is answer option D. The main thing here is knowing the equations and converting milliseconds into seconds. Again, as always, working in fractions as I hammer away. Question number 20. Rearrange the formula to make F the subject. Okay, so to make F the subject, we need to get F on its own. So first of all, let's get these together. So A over B minus C over D is equal to E over F. AD minus BC over BD is equal to E over F. Okay, so just to reiterate what I've done here, I'm cross multiplying so I can bring them together. Now we need to get F on its own. So what we can do is we can say that F times AD minus BC is equal to EBD. So F is equal to EBD over AD minus BC. And that is going to be answer option C. So what I've done here is I've cross multiplied so that I can do A over B minus C over D. And then I have just again cross multiplied, but this time across the equal sign to get F on its own. So F is equal to EBD, which is the same as BDE over AD minus BC, just by taking this down to the other side after cross multiplying. Relatively simple. Okay. Question 21 then. Which statements describe a role of mitosis? 1. Asexual reproduction. That's true. 2. Growth of a cell. No. Mitosis is growth of a tissue, not an individual cell. 3. Repair of cells. Again, no. It's repair of a tissue. Again, cells aren't tissues. Remember this. Get your key terms correct. 4. Stem cell division. Also true. Cell division is mitosis a lot of the time. So that is going to be answer option A, which is 1 and 4 only. Okay. 22. Calcium carbonate reacts with hydrochloric acid. The reaction gives off carbon dioxide gas. Line X on the graph shows the volume of carbon dioxide formed against time when 100 centimeters cubed of 1 mole per decimeter cubed of HCl reacted with calcium carbonate chips at 20 C. There was an excess of calcium carbonate chips, so this is going to be the limiting factor. Which line best represents the volume of carbon dioxide formed against time when the reaction is repeated with 50 centimeters cubed, 2 moles per decimeter cubed of hydrochloric acid reacting with excess calcium carbonate chips at 20 centigrade. So the first thing we want to notice is since HCl is a limiting factor, Initially, we have 100 centimeters cubed of 1 mole per decimeter cubed hydrochloric acid. Working by proportions, we now have half the volume but double the concentration. So therefore, the number of moles of this is the same. So the amount of carbon dioxide formed is also going to be the same. So it's either B or C. Now, simply because we are using a more concentrated acid in the second experiment, the initial rate is going to be a bit faster, so therefore line B is the correct answer. If you guys are sitting the BMAT this year, check out sigmamed.co.uk. Me and my friend Hamza put together a BMAT course that teaches you everything you guys need to know about doing well in sections 1, sections 2, and section 3. We're both Cambridge students. We both scored in the top 10% of the BMAT. I scored an 8.6 in section 2. And these are our secrets, our exam techniques, our worked examples to doing well in the BMAT. Question number 23. An object that has a weight of 15 newtons on Earth is taken to a planet where it has a weight of 3 newtons. The planet has no atmosphere. Which line on the table correctly shows the mass of the object on the planet and the kinetic energy it gains after falling from rest near the surface of the planet through a vertical distance of 10 meters? Take G on Earth to be 10 newtons per kilogram. So the formula we're working with is that W is equal to mg, 15 is equal to 10g, so g is equal to 1.5 kg. Remember, it doesn't matter which planet you're on, your mass is the same. So it's one of the last three answer options. Second equation we're working with is GPE is equal to mgh, but remember, this is the surface of the other planet. So since its weight is 1/5, its g is going to be 1/5, so its g must be 2. So that's going to be 1.5 times 2 times 10, which is going to be 3 times 10, which is going to be 30 joules. So the correct answer option is answer option E. Main thing to remember here is just the equation W is equal to mg, and that gets you pretty much everything you need to know, as well as this equation over here. Okay. Question number 24 then. Some blood is found at a crime scene. The police know that it belongs to one criminal involved. A person's red blood cells can have type A, B, both, or neither type. In a population, 45% of people have type A antigens, but not type B. 9% have type B, but not type A. 43% have neither. 3% equals both. An antibody test shows that there are type B antigens present in the red blood cells at the crime scene. What is the probability that the criminal's red blood cells have both type A and type B antigens? So of people who have type B at all, we have 12% total. 12% have B at all. This is because 45% have A only and 43% have neither. That adds to 88%, so the remaining 12% have B. Of this 12%, 3% of the overall number have both. So therefore, of people who have type B blood, 3 out of 12 is equal to 1 out of 4 are going to have both type A and type B. So essentially what we've done is we've split it into who has type B at all, and we're looking for, out of these people, who actually has both type A and type B, which is 3% over 12%, which is 1 over 4, which is answer option D. Okay, now question number 25. An experiment was carried out to investigate a gene for coat color in mice. The diagram shows the results of 3 crosses between different mice, producing 3 different families P, Q, and R. What is the maximum possible number of heterozygous mice shown in the diagram? So we can either assume that from this diagram, the easiest assumption to get the maximum number of heterozygous mice is that the gene for black coat color is going to be dominant. So therefore, this mice can be HZ, this can be HZ, and all of these guys over here can be HZ. If it was recessive, these guys would both be homozygous. These guys would all be homozygous. So if we make the assumption that the gene for dark coat color is dominant, then we can assume that all the dark mice are going to be heterozygous, and only the white mice are homozygous for the recessive white allele. We'll call it WW. So therefore, the total number of dark mice is 4 plus 4 plus 2, which is 10 plus 2, which is 12. Overall, the maximum possible number of heterozygous mice, working on the assumption that the gene for dark coat color is dominant, is going to be 12, which is the correct answer. Okay. Question number 26 then. The gases X and Y react with each other to produce gas Z according to the equation. 100 of X mixed with 10 of Y in a freely moving gas syringe with a rubber cap. The reaction went to completion. All volumes were measured at the same temperature and pressure. What is the final volume of gas in the syringe? So we have 100 of X, 10 of Y, 1 to 2 to 1 ratio. So therefore 20 of it will actually be used, and in terms of Z produced, we're going to produce 20. So overall, we start with 110, we're subtracting 20, we're subtracting 10, and we're adding back 20. So overall, the final volume is going to be 110 minus 20 plus 20, which is nothing, minus 10, which is equal to 100 centimeters cubed, which is answer option D, which is the correct answer. Important thing to remember here is the mole ratio and the fact that Y is the limiting factor since it's present in such a small volume, and we're looking for the overall final volume of gas in the syringe, not the change in volume, not the quote-unquote product volume, etc. So the correct answer option is D. 27 then. Light travels through glass at a speed which is 2/3 of its speed through air. Light travels through water at a speed which is 3/4 of its speed through air. A ray of light has a wavelength of 360 nanometers when traveling through water. What is the wavelength of this ray of light when traveling through glass? Okay, so if we call the speed of light in air v, in glass it's 2/3 v, in water it's 3/4 v, and the equation we're working with is v is equal to f lambda. So v is proportional to lambda. The larger the velocity, the larger the lambda. So if we then compare the speed of light in glass and water, we do 2 over 3 over 3 over 4, which is equal to 2 over 3 times 4 over 3, which is equal to 8 over 9. So therefore, the speed of light in glass is 8/9 the speed of light in water, and therefore its wavelength is also going to be 8/9. So 8 over 9 times 360. We can simplify this by noticing that 360 divided by 9 is going to be 40, and if 40 multiplied by 8 is therefore going to be equal to 320 nanometers. So the correct answer option in this case is C. Thank you guys for watching this 2016 walkthrough. I'm going to be releasing all the walkthroughs up until 2021, so make sure you're subscribed to my channel, and if you're studying the BMAT this year, check out sigmamed.co.uk. Thank you for watching, and make sure you're subscribed.